Okay, this is going to be the solutions to assignment 6 for Math 3274. Okay. For the first question, we are given that cardinality of A equals cardinality of B, and we have to show cardinality of the power set is equal to the two cardinality of the power sets are equal. In other words, we have to, if given a bijection between A and B, we have to construct a bijection between P of A and P of B. Okay, well, let's just think of a little idea. Okay, so, I have some subset of A, right? And I know that A1 corresponds to like B1, A2 corresponds to B2, and so on. And then, well, if I put these all together, let's just make this set correspond to this set, Okay, that's just like rough idea, I guess. So kind of by hypothesis, there exists f from A to B, and f is 1 to 1 and on to. Okay. Now we have to construct a function from the set of the power set of A to the power set of B. Okay, let's call it like capital F. Okay, construct capital F from power set of A to power set of B by f of x. So for a subset of A, that's just going to be the set of all f of little x such that x is in x. Or in other words, we get a notation like this, f of x. Okay? Now, since x is a subset of A, f of x is going to be a subset of f of A, and f is 1 to 1 and on to B, so f of x is going to be the subset of f of A, which is just B. Okay, so to every subset of A, I get a subset of B. So that definitely gives me a function from power set of A to power set of B. And this is well defined. Okay, now is it 1 to 1? Is it on to? Well, this is. I mean, you could just construct the obvious inverse to this function f. But let's just check, let's just do the boring thing, check it's 1 to 1 and check it's onto. So suppose f of x equals f of x prime. Well, what does that mean? And we have to show that x equals x prime. So that means f of x such that x is in x is equal to f of x such that x is in x prime. Okay, and we want to conclude that x equals x prime, and I guess there's like maybe a straightforward way to do this, but my thinking is that if x and x prime is different, but these two sets are the same, it will make f not be one-to-one. Like for example, suppose x is in x prime, then f of x is in the set of all, no, I shouldn't use x, I should use like maybe y. So, and f of y is going to be in this set, which is equal to this set, so this is in the set of all f of x such that x is in x. Now f of y is going to be equal to sum of x, and since f is one-to-one, that x will equal y, so therefore y has to be in x as well. So f of y equals f of x for some x in x. F is one-to-one, so y equals x, which is in x. So therefore everything in x prime is in x, and similarly x is also a subset of x prime, so x equals x prime. That tells you that f is one-to-one. What about onto? Okay, so let's check f is onto. Let y be a subset of b. We have to show that there's some subset of a which gets mapped onto y. Well, let x just be f inverse of y is all the x's in a such that f of x is in y. Now, since f is onto we have f of x equals y, so we have this. Okay, so this shows that f is one-to-one and onto a function from p of a to p of b. So here we do. In other words, they have the same cardinality. And then the second question is to kind of like inequality. So let's write down our given information. Let's see, I have kappa 1 less than or equal to kappa 2, lambda 1 less than or equal to lambda 2. I have to show that kappa 1 lambda 1 less than or equal to kappa 2 lambda 2. Well, so let's just write down that we have f going from a1 to a2, f is one-to-one, and kappa 1 is the cardinality of a1, kappa 2 is the cardinality of a2, and then we have g going from b1 to b2, and g is one-to-one, and again lambda 1, that's the cardinality of b1, lambda 2 is the cardinality of b2, and now we've written down all the information we're given, and now we have to construct a one-to-one function from a1 cross b1 to a2 cross b2. Okay, so let's define solution. Let's define capital F from a1 cross b1 to a2 cross b2 by the rule f of little a little b is going to be f of a g of b. Okay, so this is well defined, and we have to show that it's one-to-one and onto. oh sorry, just 1 to 1, but this basically is just because f and g are both 1 to 1. Okay, so f is well defined. Okay, suppose f of ab equals f of a prime b prime. Well, then we would have that f of a g of a equals f of a prime g of b prime. Oops. Yes. Okay. So now we have these two ordered pairs are equal, so they're each entry has to be equal. And f and g are both 1 to 1, so a equals a prime, b equals b prime, since f is 1 to 1 and g is 1 to 1. Okay, but then that's what we wanted to show. So the ordered pairs are equal. So f is 1 to 1. And that shows that the cardinality of a1 cross b1 is less than or equal to cardinality of a2 cross b2. In other words, this is the cardinal number kappa 1 times lambda 1, and that's less than or equal to kappa 2 times lambda 2, and that's what we wanted to do. Okay, so that's the end of assignment 6 solutions. I hope that was helpful.